Let's take a look at this question. A person standing erect can in some cases be modeled by a column of water, so just a big cylinder of water. Estimate the hydrostatic pressure difference between a person's head and foot in torr. All right, so what do we need to do this? Let's just talk about part A. First, 1 torr is 133 pascals. We'll need that because most of the units we use, like the density of water, which is 1,000 kilograms per cubic meter, require us to be in SI units, and the acceleration of gravity, which we'll use here as well, 9.81 meters per second squared. That's actually a little bit less than that here in the delta because we don't have any iron or ferrous rock anywhere nearby. All right, so the change in pressure between the top of your head and the bottom of your feet goes as the density of water, right? Because that's the the model we're using here, that you're basically a big column of water times gravity times the change in z, which is your height, right? Now we could talk a little bit about the fact that pressure due to the atmosphere goes up, but given that the density of the atmosphere is about 1.29 kilograms per cubic meter compared to 1,000 per cubic meter for water, we're just going to ignore that right now. And how tall are you? Well, let's just go with a height of, so we got 1,000 kilograms per meter cubed. We've got 9.81 meters per second squared, and let's just say 1.85 meters, 185 centimeters, right? So what are we going to get if we pop over to Excel and we've got 1,000 times 9.81 times 1.85, right? So 148.5 148.5 pascals. All right, but we want this in torr. So that's going to be the 148.5, not that the 0.5 matters, divided by 133 to get us to torr. Let's go over and get that number real quick. Equals that divided by 133, 136.5. 0.5 torr. 136.5 torr is the typical difference in pressure between the top of your head and the bottom of the feet, right? So why then, let's look at parts B and C. They are much more discussion. Why then, when they take your blood pressure, do they want your arm elevated up close to the level of your heart? Why? Because they're trying, right? Trying to take the blood pressure at your heart, and you need to take out this difference in pressure due to elevation. All right, let's play with this a second. Let's say you're holding your let me bring up Excel. Let's say you're holding your arm down below your heart, and they're taking the blood pressure just 10 centimeters down. Well, that's 981 or pascals or 7 torr. That might be a significant difference in trying to measure this, right? That's a so we like to have the arm elevated a little bit when we do that. Also, our body's adapted to living with most of the pressure on our feet, right? So when you stand on your head, you feel that increase in pressure in all the vessels in your head and in the muscles and everything in your head, because that's just not how we're designed, right? We're designed to be upright or laying down at the most, right? Okay, that's it for this example. Hopefully this helps.